Hello everyone. We have started with curve tracing of Cartesian curves. In that we have already studied first four rules, that is symmetry, then to find out point of intersection, then asymptote, and the major rule here is the how to figure out region of absence for the given curve. Okay, what I mean by region of absence is in which region the curve will lie, so that it will be great idea to decide where the curve is not present, right? So the first thing here we are going to do is expressing y as a function of f of x. If it is possible, if, express x in the as a function of y. It depends on question whether you can just express y as a function of f of x, or you can express x as a function of f of y, right? So either one of them try to write down in one of the form. Okay, and once you uh, just write down like this, it will be easy. If you change value of x, what are the changes in values of y? Or if you express this in terms of x is equal to f of y, then in that case if you change y, then what is the difference in x, you can observe that. Okay, so it is great idea to express that one of these two forms. Okay, then the next thing, once you express it as y equal to f of x, for now I'll consider y equal to f of x. Same things you can do it for x is equal to f of y. Okay, so once you are able to express y equal to f of x format, then just observe that for which values of x y becomes either negative or it becomes imaginary. Okay, why we are considering imaginary here? Because suppose I have a curve like y square is equal to f of x, right? And for some values of x, y square become negative. So in that case y square is imaginary here, because for real number, no real number is having square is equal to negative number. So that means surely that part for which it becomes negative, surely it is absent in our curve, right? So that's why it is important to express in this format, right? And similar thing you can do it for x is equal to f of y. Okay, then the next thing, uh, suppose y equal to f of x is given, and if you consider uh, the square term is not there, that is y is just y equal to f of x, y square is not there. Okay, so just will observe that when x is becoming negative, what happens with y. Okay, that is when you are uh, going left towards left, what happens with y, you can decide. Okay, so using these rules we can decide what is the region of absence for the given curve. Okay, now how it proceeds, right? Let's take example based on this. My first example here is y square is equal to y square into 2a minus x is equal to x cube. The first thing we are going to do is expressing it as y equal to f of x, or x is equal to f of y, right? So here it is easy to express y as a function of x. So I'll write down the same function as y square is equal to x cube divided by 2a minus x, right? Now note that firstly, when x is negative, in that case what happens when x is negative, x cube is going to be minus of this term, and x is negative, so it will become plus, so there is no problem with denominator. But when x is negative, numerator become negative. Because of numerator, the whole term will become negative. Since the whole term is negative, y square becomes negative, and hence square cannot be negative, so that means x cannot be negative number here, right? So what is the first condition you got here? When x is less than 0, what happens with y square? Y square also become less than 0, right? So that means y becomes imaginary. Right, so I cannot include x less than 0 part in my uh, diagram, right? Now what about the denominator? Now note that what is denominator is 2a minus of x. Suppose x is greater than 2a, then in that case again this becomes negative, and because denominator is negative, the whole term will become negative, and again y square results in negative number. So this should not happen, right? So what is case 2 here? Case 2 is when x is greater than 2a. When x is greater than 2a, so in that case y square again become negative, so y becomes imaginary. So I cannot include this part again, right? So how my diagram will look like? This is your x-axis, y-axis 0, x become negative in this part, so this part is not included in diagram, right? This is absent, right? Then suppose this is 2a point, so this is x is equal to 2a line. If x becomes greater than 2a, so again this become imaginary, that means this part is also absent, right? So that means this is the region where we are going to trace our curve. Okay, it is simple as that. Okay, so whenever there is a negative number present in the denominator, you need to just consider x term bigger than this, so that it may become negative. Okay, so what I did here, firstly I check when x is negative what happens, and when in the denominator term becomes negative what happens, right? And this is it. Let's take one more example. Let's see, suppose I take next example as y is equal to y into 1 plus x square is equal to, let's take x, right? Again it is easy to express in terms of x function, so let's write down this as y is equal to x upon 1 plus x square, right? Now note that this is not a square term, right? So same the rule which we applied in above diagram, it is not applicable here, because this is just a y term, that is if x is negative, yes y may be negative, there is no problem for that, right? So I cannot consider the same thing here, right? That is by changing in values of x, what happens with y, I cannot just apply the thing here because the square term is not present here. So how to proceed in this case? We will check for say 4 5 values for x, just substitute 4 5 values of x, and let's see what are the changes in y. Okay, why we are doing this? Because by just making x negative, it we cannot decide what happens to y, right? So I'll just consider, let's take some set of values. Let's start with simple values 0 1 2 3, let's take 4 5, right? Let's take this values. Okay, so when I substitute x is equal to 0, clearly y is also 0. When you substitute x is equal to 1, what is it? 1 upon 1 plus 1 is half, so this is 0.5. When you substitute 2, this is 2 upon 1 plus 2 square is 5, so 2 upon 5, so which is 0.4. When you substitute 3 here, this is 3 upon 1 plus 3 square is 9, so 3 upon 10, so that is 0.3. When you substitute 4 here, this is 4 upon 4 square is 16, and that is 17, right? So 4 upon 17, so that is nearly 0.2, right? When you consider 5 upon 26, right? So which is nearly equal to 0.1 or something, right? So you can observe that what is the behavior of x here and accordingly y, right? So I'm just trying to draw the diagram here, right? For x0, y is also 0, and for x is equal to 1, y becomes just thoda sa upward, right? 0.5, and again from 0.5 it is dropping, right? So curve will shape like this. Okay, this is not a whole curve, but this is half part of the curve, right? So when you are not able to decide, that is if x is negative, what happens with y, then in that case straight away take some value set for x, accordingly find out values of y, and then try to plot the graph. Okay, and that's it. Let's take one more example here. Let's take third example. I have here one example. A square x square, this is equal to y cube 2a minus y, right? Now clearly I can express the given curve as a function of y. I'll write down this as y cube into 2a minus y divided by e square, right? And now here in the case square term you got on the left hand side, so let's check out when this become negative, what happens, right? So if y cube 2a minus y divided by a square, so it will go to this side, so it is ultimately 0. So when this is less than 0, so x square will be 0, less than 0, and x becomes imaginary, right? So this point of set is not included, right, where it becomes negative, right? Now let's try to simplify the point of set. What is exactly that point of set? That is y cube into 2a minus y, this is less than 0. What does this imply? Product of two terms is less than 0, that means one of them must be less than 0, right? So y cube, this must be less than 0. In that case, yeah, I can take 2a minus y greater than 0. Or what is the second condition? Ki y cube greater than 0 and 2a minus y, this is less than 0, right? So what is the point set here? Y less than 0 and 2a is greater than y, or y greater than 0 and 2a is less than y, right? So what is the region here? 0. Suppose this is 2a, then this is minus 2a. So it depends ki what is the intersection point of given curve with y axis. Okay, if intersection gives 2a, then area of presence is going to be this one and other one will be absent. If intersection is minus 2a point, then area of presence will be this and this area will be absent, right? So for this, rule 3 is important. What was rule 3? That is checking intersection of given curve with coordinate axis, right? So if the curve has intersection 0 comma 2a, then that will, here you will get the tangent, so that the curve will look like this. If the minus 2a is there, then the curve will look like this. So the major part playing role here is the intersection with axis, right? It depends on that. So that's all for now.